Hello again, Paul Watts here from High Flying Physics, supporting students wanting to get A grades. Here's another exam question which I want to go through, which is looking at the tension between a string connecting two masses, with one mass towing another mass. It picks up on a slightly sort of problematic area of tension in a string, particularly with the idea that the tension in a string is acting in both directions along the string. Let's have a look at it. Two masses of 5 kilograms and 12 kilograms are connected by a light inextendable string. They are resting on a horizontal frictionless surface. A horizontal force of 22 newtons is applied to the 5 kilogram mass. What is the tension in the string connecting the masses? Okay, let's have a look at the force diagram then. I've drawn the tension acting to the right there along the string from the 12 kilogram mass. So that's what we're trying to calculate. So to begin with then, because those two masses, the 12 kilograms and the 5 kilograms, are connected by an inextendable string, we know that they're both going to be accelerating at exactly the same rate. So we can work out what that acceleration is by working out the total mass, which is 17 kilograms. There's no frictional force acting. So in other words, the 22 Newton force acting to the right is effectively the resultant force, and we know the resultant force is mass times acceleration. Reorganizing that for acceleration, we can say 22 divided by 17, and that comes out to be 1.3 meters per second squared. So that's the acceleration of both the 12 kilogram and the 5 kilogram mass connected together. Okay, so now what we're interested in is the 12 kilogram mass, and so let's take that in isolation. So we can draw our diagram which looks something like that. So there's our 12 kilogram mass, there's the acceleration which we've just worked out is 1.3 meters per second squared, and we're trying to find out T, the tension. So again, the only force acting forwards on that 12 kilogram mass is the tension, in other words force, which is equal to ma. We know we've got a mass of 12, the acceleration is 1.3, and that tension comes out to be 15.6 newtons. So that's the answer to the question. So we could leave it there, but let's do a check. Let's just make sure that calculated tension is correct. If we take the 5 kilogram mass in isolation, we should be able to work out its acceleration, which should obviously match the acceleration that we've already worked out, which is 1.3 meters per second squared. So there's our 5 kilogram mass. We've got the forward force there of 22 newtons. We've got the tension now, which is 15.6 newtons that we've just calculated. And remember that tension acts in both directions along the string. So the unbalanced force on the 5 kilogram mass is 22 newtons minus the 15.6 newtons, and that's going to be 6.4 newtons. Then we can work out the acceleration, which is the force, which is the unbalanced force, which is the 6.4, divided by the mass, 5 kilograms. And thankfully, it confirms the acceleration that we've already calculated as 1.3 meters per second squared. Very good. I hope you found that useful, and we'll see you soon. Thanks. Bye.